You've talked a lot about quadratics, but how are they even helpful? Well, there's lots of applications of quadratics, but let's talk about kind of a more basic type of problem that you see in almost every algebra textbook. In this problem, we're going to start with a rectangular piece of cardboard, so I'm going to sketch that out, where the length is 12 more than twice the width. So they don't tell us anything about the width, so I'll just label that W. But the length is 12 more than twice the width. So I double the width and then I add 12 to that. Then we're going to take our corners and cut out 3-inch squares. And that allows us to be able to fold up the corners to create a box. So you can kind of picture that 3 inches that we just cut out is going to fold up, and that will create the height of our box. So I also know that once this is a full box, my height is going to be 3. And then the last thing they tell us is that the volume is 972 cubic inches. And they want to know, what are the original dimensions of the box? Well, I know that volume is length times width times height, so let me use that and substitute in what I know to create a new equation that I can solve. But something that we need to be careful of is that the original length of your cardboard was that 2W plus 12. That's the entire length of the cardboard. But once you fold it into a box, part of that lip around the outside becomes the walls of the box. So it's not the length of the actual box. So if I were to draw the actual box, it would look something like this. Now that height we already talked about is 3 because I cut out a 3-inch square from the corners of my original piece of cardboard. But the length was 2W plus 12, but we cut out 3 inches from the left side and the right side of that piece of cardboard, so that once I fold the box up, my length goes down by 3 inches on the left and 3 inches on the right. So we decrease this by 6 to get the length of the actual box being 2W plus 6. And then the width of my box, same thing. Our width used to go from top all the way down to the bottom, but now we're cutting out those squares, so my width only starts here and ends here. So it was W, but once I fold it into that box, we subtract 6 to get the width of the actual folded box. So then my volume has a length of 2W plus 6, a width of W minus 6, and a height of 3. And we know that that all turns out to be a volume of 972 cubic inches. So let me simplify that right-hand side, and then we'll be able to solve. Since I now have a quadratic, I'm going to get 0 on one side and maybe factor or use the quadratic formula to solve. I do notice that everything divides by 6, so let me go ahead and do that. And I will factor. Now, since we're talking about a physical object here, I have 2 answers, but the negative answer isn't going to make any sense. So I've got a width of negative 12. That's not going to make any sense. So I know that my width has to be 15. And then we can go back and say that my length was 2 times W plus 12. And now that I know W, let's just put that in and we can find L. So that's going to be 30 plus 12, which is 42. So the original dimensions of the cardboard had a width of 15 inches and a length of 42 inches. And that's an application of a quadratic. Thanks for watching. I'll see you next time. Bye.